And now in the next part, it asks us something more elementary, but it asks us to do it with these series. It asks us to consider the graph y equals f of x minus g of x. It says it passes through the point 0, -1, and it wants us to find out what y prime at 0 is and y the second derivative at 0. So we can do that pretty easily because when we can first find out that for y prime at 0, that's just going to be equal to f prime at 0 minus g prime at 0, which when we look at our Taylor series, f prime at 0 is equal to -0/2. Oop, I should take the derivative first. So what we first have to do is let's do term-by-term differentiation and plug in 0. So f prime of x will be -1/2 plus 4x/3 minus 9x² over 4. And hopefully at this point, you notice since we're plugging 0 in, these terms are going to disappear. Now I don't want to totally delete these terms because when I do the second derivative at 0, I'm going to need them. So I can say that for f prime at 0, I know that that's equal to -1/2. And now I'm going to find the formula for g prime of x, which is going to be 0 minus, this will be -1/2, because it's x over 2 factorial, which is x over 2. And then when I take the derivative of this term, I'm going to get 2x over 4 factorial. So this will be 2x over 4 factorial. And my next term will be, using this one, it will be -3x² over 6 factorial. So I think that'll be enough terms for what I need to do to come up with these values of the first and second derivative at 0. And as you can see here, my second derivative, or my first derivative at 0 is going to be g prime at 0. When I plug 0 in, again, this part's going to be -1/2. So I have, for my first derivative, I have -1/2 plus 1/2, which is 0. The next part is finding y prime at 0, which will just be f prime at 0 minus g prime at 0. Well, from this previous equation, you can see that f prime at 0, as we work it out, will equal 4/3 minus the derivative of this term is going to be 18x over 4, and if I'm sorry, this will be evaluated at x, which when I plug in 0, that will just equal 4/3. The other portion, when I do g prime at 0, is going to be the derivative of 0, 0 of -1/2 is 0, of 2x over 4 factorial is going to just be 2 over 4 factorial minus 6x over 6 factorial, blah, blah, blah. But when you plug in 0 for that part, you're just left with 2 over 4 factorial. So, carrying on, I have my f prime at 0 is going to be 4/3. And my g prime at 0 is going to be 2 over 4 factorial, which that's 4 times 3 times 2 times 1, which will be 24. So I'll have 2 over 24, which results in 4/3 minus 1/12. So what we can see here from this is clearly going to be positive. It's 4/3 over 12. It's 16 over 12 minus 1 over 12, which is going to be 15 over 12. So that tells us our second derivative, y prime prime at 0, is positive. And that's the really most important part, is that tells us it's positive. We know that y of x is concave up, where y prime of x is where the derivative is equal to 0, where we have a possible relative max or min. Well, now, because we know what the second derivative is in the concavity, we use a second derivative test, and we can conclude that at this point y x equals 0 must be a location of a relative min. I hope this has helped you with working through this problem. Hopefully you tried this on your own before listening to the solution. And just remember, ask me any questions when you go over this in class. This again is an AP question that's been released. I'm not claiming any credit for it. I just want to help you understand how to work through the problem before the BC test. So we'll talk to you guys later. Have a good day. Bye.